Stanley, can you give us some idea about the size of a conversion kit for a car, for instance? We see all this electronics sitting there, but I guess this is not going to be part of a future upgrade kit for a car, is it?
No, basically what this was a pre-engineering unit in order to satisfy the U.S. Code of Operability on Section 35, Section 101, and it was developed as pre-engineering to show the operability of all the different operational parameters of water fuel cell. But in actuality, the entire technology you see here is really reduced down to the water fuel cell injectors you see right here.
This is the only thing that's needed for upgrading a car, or is there anything else involved?
No, the water fuel cell injector, which replaces the conventional spark plug in an internal combustion engine, this is hooked up to a water tank. Basically, if you have a plastic fuel tank in your car, you simply drain out the gasoline, flush it out, fill it up with fresh water. Then the water fuel cell injector now allows the water to be transferred. The system approach allows the water to go in to the injector, which is now being processed to release the thermal exposure energy from hydrogen. The second part that's hooked up to it is what we've referred to here again as the gas processor that's ionizing the gas to allow it to come in. So basically in retrofit, all we're doing is simply tapping off the exhaust gases from the conventional engine. We're now using the gas processor to utilize the ambient air to ionize the gases, which is now mixing with the water, which now converts it to water fuel. We allow the water fuel to go into the injector that's now plugged into our replaces your spark plug and allows the engine now to run off the thermal exposure energy from hydrogen. So basically, all we're doing is taking the gasoline out of the tank, fill it up with water. We now replace the spark plug with the water fuel cell injector, and we now hook a small little miniaturized computer which controls and meter mixes the gases going into the engine to allow the engine to accelerate and deaccelerate. So the installation is a very small, lightweight, compact electronic control system.
Okay, now the distributor, is that going to be the same? Can I use the same distributor, or do you have a modified version, or is there anything additional to it? Can you explain about that?
We do modify the distributor as it's shown over here. We simply take off the conventional rotor cap out of a conventional engine, and we put the laser distributor in between the distributor assembly and the cap, and this now sends the signals to the computer system, which will really be a composite of several IC or integrated circuit chips that miniaturizes the hydrogen computer system.
Okay. This whole hydrogen stuff, isn't it extremely explosive in the car? Is there any danger involved? What's the safety aspect of it?
No, we have actually solved the problem. There's no storage of hydrogen whatsoever. The water goes into the injector, which now allows it to go into a high pulse voltage zone, which performs the electrical polarization process. So the water is only converted into thermal explosive energy as it enters the injector, so the thermal explosive energy is now occurring inside the engine. So the electronic system is designed to regulate and control the explosion of the energy, which now co-equals that of gasoline, so it's a tremendously fail-safe operable system.
Okay, so it's safe, it's a small system.
Yes.
What about maintenance of the car engine itself? Do I need more maintenance? Is there a difference? Is there anything, do I have to modify anything on the maintenance schedule?
No, just keep the same maintenance as you have it. Since you're releasing thermal explosive energy into the engine and you're co-equaling the burn rate of gasoline, then there's very little maintenance. If there is any maintenance at all, we developed the technology years ago that we could really impregnate the cylinder walls of the engine with Teflon, and we can even treat the bearings and literally run an engine off of the Teflon and eliminate the oil. If that occurs, then you can use a product something like Slick 50 in the engine if you would need it. But the wear factor, since it's a very clean burning fuel, hydrogen is a very clean burning fuel, then the engine oil is not contaminated under the old method of running on gasoline or diesel fuel. So it's an extremely clean burning fuel.
Are we on? Yeah, the red low temper. Good, Stanley. What about the valves in the engine? The pistons, don't the pistons burn out because there's no lubrication of the lead or any other additives to the usual gas.
Now the valves, have been designed very recently to operate off of non-leaded gasoline, and since we use the exhaust gases to cycle back in to modulate the burn rate of hydrogen gas, as we now control the burn rate to co-equal gasoline, then the engine temperature and operations are duplicating the same thing on gasoline or diesel fuel. So you don't change the engine in any way. And this allows us now to retrofit the water fuel cell technology to any existing engine. And that's very important because it now gives us the ability that we can stabilize transportation, as we talked about before, if the energy is cut off.
Okay, so now the accelerator. Can I still keep the same mechanical accelerator, or do you have a new device for that as well?
Yes, we developed over here as we come along. We've developed the what we call a laser accelerator, as you see right here, that simply is attached to the accelerator pedal, and it as you press the pedal down, the gas pedal down, it displaces the mechanical displacement into electrical impulses, which now is fed into the micro-miniaturized computer electronics. So this gives us the abilities now to control the acceleration. This type of technology has given us the abilities to equal or supersede the performance of acceleration and deacceleration on conventional cars that's running on gasoline or diesel fuel. So the hydrogen, being 2.5 times more powerful than gasoline, gives us a tremendous amount of performance over the prior state of the art. It runs very smoothly, and it has a very unusual sensation. Generally, when you're running a car on gasoline, you have this kind of a pause. But when you're running on hydrogen, the way we're doing it, it's a constant acceleration. So it's a extremely very fast responding fuel source that's coming from water.
So you're claiming that performance is equal or better as a normal gasoline car?
Oh yes, definitely. It'll even start up quicker. In the wintertime, you're dealing with a liquid gasoline or liquid diesel fuel, and you have problems in starting. In cold weather, you don't freeze gas atoms, and so by converting the water into instant energy, gives us the ability to start the engine very, very quickly.
When you start an engine in the morning, for instance, how long does it take before you can drive away?
Oh, it's an instantaneous startup. Immediately when pulse voltage frequency hits the water, it converts it to the gas, which now produces a thermal explosive energy. So it's an instant type of start.
Okay.
The electronic circuit interfacing gives us the abilities to control and meter the amount of water that's going in on the start condition as opposed to on a run condition. So the computer automatically adjusts between the start condition and the run condition. So electronically, we have the abilities to adjust for these parameters. And the same as a conventional car, we also have the abilities to adjust for different ambient air conditions going from sea level up into the mountain ranges. So automatically, the electronic circuitry design gives us the abilities to adjust these parameters to give us a very smooth operational performance.
But what about air pressure? I mean, when you go up high in the mountains, you don't use ambient air, so this has no influence on the performance of the car.
No, if you come over here, here we have a device of the metal bellows, which now allows to control the amount of ambient air going into the engine of the car. And this automatically allows us to regulate the ambient air pressures going from sea level up into the mountain areas. So electronically, these solenoids you see here have sensors that automatically senses the amount of ambient air pressures, and they're automatically electronically adjusted to compensate it for difference of air pressure. So this allows us now to give us tremendous good performance going from sea level right on up into the high mountain regions.